In our last class, we got introduced with weighted code, especially BCD or binary coded decimal, and we have seen that that has weight 8421. And in number system, if we have a code, definitely that will have some applications. So now we will see how we can use BCD code to perform arithmetic operations like addition and subtraction. In today's class, we will learn about BCD addition, and in the next class, we will learn about BCD subtraction. So first we will start with algorithm, and then it will be followed by a few examples. So this is just a small recap that we have already learned in our last class, that in case of BCD binary coded decimal numbers from 0 to 9 are represented by using 4-bit binary. It's normal mapping between decimal and binary, but here in case of BCD, the representation is like every digit in decimal will be represented by 4-bit binary, whether we need all those 4 bits or not. But we know that using 4-bit in binary number system, we can represent maximum 15 digits in decimal number system. But here we are representing only 10, 0 to 9. That means rest 6. Those 6 numbers are invalid in case of BCD. So from 10 to 15, these are invalid code in BCD. Next, we will learn how we can perform BCD addition. So first we will learn the algorithm, means the rules. Suppose we want to add 2 plus 3. 2 and 3 both are in decimal number system. And in decimal number system, if we add these two numbers, then the result will be 5. It's simple. Everyone knows that. But how we can perform this, how we can get the same result by using BCD code. So what we do in the first step is we convert the numbers that we want to add into their equivalent BCD code. So the first number is our 2 and its corresponding BCD code, as we know, that is 0010. Now the second number that we want to add with 2, that is 3. So we know, we have learned that the BCD equivalent of 3 is 0011. Now what we will do? The second step says that now after converting these two numbers into their equivalent BCD codes, we will simply add them. And here the rule of binary addition will be followed. So we have already learned the rule of binary addition in one of our earlier classes. So 0 plus 1, it will be, as per the rule of binary addition, it will be 1. Then 1 plus 1, it will be 2. That means in binary, it will be 1, 0. So here we will have 0, and then the 1 will be carried forward to the next bit. So here 0 plus 0, 0, and this carry 1. When it will be added, then it will become 1. And there will be no carry. Simply at MSB 0 plus 0, it will be 0. That means the final result of addition will be 0101. And what is the equivalent of 0101? That is in decimal number system, that is 5. That we know, that we have already learned. Now what to do? Next, we will check the result if that is valid. And what is the valid range? Valid range is 0 to 9, and 5 is within that range. So this is a valid number in BCD. So if it is valid, that means if it is less than or equal to 9, then no correction is needed. And that is the final result. So here the final result of addition will be 5. But if it is more than 9, then what happens? That rule also we have to know. So if it is more than 9, if it is greater than 9, then we have to go to the next step. So what is waiting for us in the next step? Next step says that add 0110. And what is 0110? 0110 is the BCD or binary equivalent of 6. Here we have seen that in BCD we have 6 invalid codes. So we are adding 6 here with the result of binary addition, which is invalid for the time being. So when we will be adding this 6 or 0110, then finally it will become a valid number, and that will be our final result, and that will be within our range, so that will be acceptable by us. So this idea, these rules, this algorithm will be more clear when we will solve different types of numericals. So first what we will do, first we will add two single digit decimal number. So here as we can see, 7 plus 9. So 7 plus 9 in decimal, if we perform that addition, then it will be 16. Now we'll keep aside the mapping between BCD code and decimal digit so that it will be helpful for us to perform the addition. Now 7 in the first step in the algorithm we have learned, first we have to convert those decimal numbers into their equivalent BCD code. So here the two numbers are 7 and 9, and what are their equivalent BCD code? 0111, and for 9 1001. Now in the next step we will perform simply the binary addition. So 1 plus 1 1 0. So here we will write 0 and 1 will be propagated to the next bit. So here 1 plus 0 1, and with that 1 1, so it will be 1 0, again 0 here, then 1, this carry will be propagated, then 1 plus 1 1 0, so 0, and here again there will be 1 carry, so 1 plus 1 0, and there will be another carry which will be propagated, which will be, since this is the final bit MSB, so we will write straightforward that carry, the final carry here. But here if we look at the first 4 digits of this result of addition, we can see that all are zeros. Apparently it may seem to us that 0 is a valid BCD code and that equivalent decimal digit is 0, but it is not, because here this the finally when we perform the addition for MSB, then that addition also generated one carry, and this is the carry, and that we have propagated to the next level. That means only 0000 is not the result of addition in our case. We have to consider this carry also, and when we consider this carry, it becomes an invalid code in BCD. So what we have to do is, since this is invalid code, as per the algorithm we have to add 6. 6 means the binary equivalent or BCD equivalent is 0110, and again we will perform binary addition. So 0 plus 0 it will be 0, 0 plus 1 it will be 1, fine, 0 plus 1 it will be 1, 0 plus 0 it will be 0, and 1 there is nothing to be added, that means 0, so it will be 1. So what will be the result of this BCD addition? We will split into groups of 4 bits. So in the first group we will have 0 1 1 0, and in the second group we have only 1. That means we can think of 3 more zeros before that. So this will be the second group where we will have these 4 bits. Now 0 1 1 0, what is the equivalent decimal number? The decimal equivalent is 6. So that means here it will be 6 in decimal, and then 0001 00001 means it is the decimal equivalent is 1. That means the result of this BCD addition is what we have obtained here, and if we want to think in terms of decimal, then it will be 16. Now next we will perform BCD addition using two-digit numbers. So here we will perform this addition between 39 and 82. And in decimal number system, if we perform this addition, then what will be our result? We know. All of us know that 1 to 1 in decimal. But the same addition, if we want to perform using BCD code, then how we can? So first again, we will keep that mapping aside so that it will be helpful for us. And now as per the algorithm, first we will convert both the digits in decimal to their equivalent BCD code. So 3 and 9. So this is 3, this is 9. So we will write them accordingly, and then 8 2. This is our 8 and this is our 2. So these 4 digits we need. So next we will perform binary addition between these two numbers. Now we have to see whether the result of addition that we have performed digit wise, whether these two values 1011, both the digits are same, both the values are same here. Now we have to see whether these values are within the valid range or not. So next we will see the invalid range, the invalid codes. 1011, 1011, what we can see here, this is the invalid number in BCD, and if it is invalid, then what we have to do? We know that we have to add 6 to that result. That means 0110. So here 0110 will be added with this invalid digit or invalid result, then again 0 1 1 0, since this also is invalid, so the same value will be added, 0 1 1 0. And now again we will perform BCD addition or binary addition. So here it will be 1 plus 0 1, then 1 plus 1 1 0. So here 0, and we will have carry that will be propagated to the next bit. So 1 plus 1, it will be 1 0, again 0 here, and then again we will have carry here. So 1 plus 1, again it will be 1 0, so 0, and that carry will be propagated to the next digit. So here it will come. So now again 1 plus 1, it will be 1 0, so 0, then we will have 1 carry, 1 plus 1 1 0, and with that 1, when we will add this 1, so it will be 1 1. So here we will have 1, and that carry 1 again will be propagated to the next bit. Then 1 plus 1 1 0, so here we will have 0, and then 1 will have carry 1 here, 1 plus 1, it will be 1 0, so 0 here and 1 here. Now we have to see whether these results are valid within the valid range or not. 0 0 0 1, definitely it is valid, and that is equivalent is 1, so this is valid. And 0 1 1 0 0 1 1 0 is true, so that is also valid, though it has generated 1 carry. But since we have in this step itself, we have added 6 already with the previously obtained invalid number. So this time 0 0 1 0 will be considered as a valid number, and definitely this carry will be considered separately, that will come under the separate group of having 4 bits. But since this is one single bit and that has value 1, so we can again think of 3 zeros before that. So this will be in the result of addition, this will be our third group. So this is the final result of this BCD addition. Now if you want to verify with the decimal value, then we can easily do that. 0 0 0 1 is what? The decimal equivalent is 1. Then 0 0 1 0 0 0 1 0, the decimal equivalent is 2. And then 0 0 0 1, again the decimal equivalent is 1. So in decimal number system, the result of this addition should have been 1 to 1. Next we will perform BCD addition between two 3-digit decimal numbers. Now in decimal number system, if we perform this addition 121 plus 596, then the result in decimal number system will be 717. But this addition we want to perform using BCD codes. Again we will keep the mapping aside, which will be helpful for us. So in the first step we will convert both the digits in their equivalent BCD. Now we will perform binary addition, and this result is divided into 3 groups, and in each group we have 4 binary bits, and we have to see whether every combination is valid or not. This is our valid range and this is our invalid range. Now 0 1 1 1 0 1 1 1, what we can see is this is the decimal equivalent is 7, and that falls within valid range, so this is valid, that is acceptable. 1 0 1 1 1 0 1 1, what we can see is the decimal equivalent is 11, so this is invalid. So what we have to do is, with invalid code we have to again add 6, the normal rule. And now the next group is 0 1 1 0 0 1 1 0 means 6, which is valid. So here only with the second group we have to add 6, because this result of addition is invalid. Now again we will perform binary addition. Now we may think that what will happen to the other groups. So what we will do is, when we will perform the next level of binary addition, straightforward, for the valid digit we will take that valid value, so 0 1 1 1, or we can think this way, as if we are adding 0 0 0 0 with that valid code. So in the first group we will have 0 1 1 1. In the second group, now you have to perform this binary addition. So 1 plus 0, it will be 1. 1 plus 1, it will be 1 0. So here you will have 0, and then there will be carry 1. 0 plus 1 1, and then with that 1 again 1 0, so 0 here, and then we will have carry 1. Then 1 plus 1, it will be 1 0, so we will have 0 here, and we will have carry that will be propagated to the next group. So here we will add 1, then 0 plus 1, it will be 1, then straightforward it will be the remaining bits, and since there is no more carry, so the remaining bits, they will remain as they were. So in the second group now we have 0001, so 0001 is valid, and in the third group we have 0111, and 0111 is also valid. So this result is our final result. This is valid result. And now if we want to verify with our decimal result, then we can easily do that. So 0 and 111. 0111 is what? The decimal equivalent is 7. And then 0001, the decimal equivalent is 1. And then again 0111, the decimal equivalent is 7. So here in the decimal number system, the result would have been 717, and that we have already verified, 717. That means this result of BCD addition that we have obtained by following all the rules is the correct one. So this is how we perform BCD addition by following all the rules. So I hope this class was helpful for you. In the next class, we will be performing BCD subtraction. See you in the next class. Thank you.